Hey there. Yeah, so these ones are kind of a bummer. Let's see. So we have an object is thrown upwards with the speed from that height, and it's modeled by that equation. Round to two decimals. When will the height be 64 feet? Okay, so the height is the output on this equation, and so we would be setting 64. Oops, that didn't work. 64 equals negative 16t squared plus 130t plus 9. So they're asking when the height would be 64 feet, so I'm plugging that in for h. If you think about what this would look like, this graph, it would be a parabola opening down because of the negative in front, and it would have a y-intercept of 9, so that's that. It's being thrown from a height of 6 feet off, or 9 feet off the ground. So it would go up and it would go down, and we'll pretend 64 is right there. And so we're trying to find the x values, the time, because it's asking for when, so that means we're solving for t, when that would happen. So those two values, when it would cross over 64 feet. So this is we know the output, we're looking for the input. I do hate a negative leading term, so I'm going to bring everything to this side and rewrite this as 16t squared, and that will make a minus 130t. And then I'm subtracting the 9 over, so 6055 equals 0. Don't think that factors. That looks pretty ugly. And so from there we would do quadratic formula. So we would say t equals negative of negative 130 would be 130. The plus or minus square root negative 130 squared minus 4 times a is 16 times c is 55 all over 2a, so 2 times 16. And I think I just posted a video on evaluating when the numbers are kind of big like this. But basically all you're going to do is make this mess under here a number, and then you'll do 130 and then take the root and then do 130 plus that number divided by 32. That'll be your first answer, and 130 minus that number and then divided by 32, and that will be your second answer. And if you do that right, those should come out to 45 and then 7.68. So it's like this is 0.45 right there, and this one is 7.68 if we're looking at those x values. When will the object reach the ground? That's basically the same thing, but now you're just setting, instead of 64, you're just setting this to 0 and doing that exact same process again. And you can see it started off at 9 feet, so it did not start off at the ground. So all we're doing is finding this x-intercept. There'll be a second x-intercept when you do that. It'll be a negative value, which is meaningless because it's the one that exists mathematically, but since it's starting here at 9 feet, it doesn't make sense in terms of the problem. So when you redo this, you're just going to want to do, again, the quadratic formula with those numbers, but you're only worried about the positive root because you're looking for that point right out there. Hopefully that helps, and if you do that right, it should come out to 18.19 when you do that one. Holler if you still have a question.